All right, thank you everybody for coming today. Really appreciate you coming out with especially the weather being a little bit cold this past week. Um, my name is Elizabeth Bialowski, and I'm the Programs and Operations Manager at the Environmental and Energy Technology Council of Maine. I don't really need the slides if, yeah. That's okay. I'll do this part without it. So our event today is part of an ongoing climate incubator series that we've been doing in partnership with the Rue Institute at Northeastern University, which we're all at today, and funded by the Governor's Energy Office. The overall goal of this ongoing series, and it's nice to see so many familiar faces here today who've been to some of these events before, is to promote a network of professionals and organizations and businesses and entrepreneurship programs across Maine that are working on climate innovation and technology innovation, and especially integrating the two things. So a little bit about the Environmental and Energy Technology Council of Maine, also known as E2 Tech. We are one of the nonprofits for the past 20 years that have been leaders in building and expanding the state's environmental, energy, and climate sectors, and also building a network of 4,000 plus professionals, 50 partners, and over 225 members. And part of the way that we build that membership is through promoting events and forums and educational opportunities and networking events with professionals such as yourself that have relative expertise in this field, and sharing those ideas so that we can move forward to decarbonize our future with the urgency and expertise that it requires, with also acknowledging that we have so many of those people in this space with us right now. And lastly, one of the papers that you have in front of you is on this Maine internship program. One of our partners, the Northeast Energy Efficiency Partnership, does an internship program that we also work with that helps place interns across Maine in clean technology and clean energy positions. So if your organization is potentially interested in having one of these internships, there's more information on the sheet, and please feel free to get in touch with me today about this as well. And lastly, also with our Climate Incubator series, we have another event coming up on January 26th at the Rue and Hybrid. January 22nd, that's the Rue and Hybrid, from 12 o'clock to 1 with Silicon Valley Bank and Heat Map News that'll be focused on a discussion around the future of climate technology as well as climate funding. I'm going to pass it over now to my colleague Tara at Northeastern Rue Institute to share a little bit more about the Rue as well as our program for today.
Thanks so much, Elizabeth. Hey, everybody. Thanks so much for coming. Happy New Year. Like Elizabeth said, we do these programs about twice a month. Hybrid most of the time, at the room most of the time, but you might find us around the state as well. So thank you for coming and for being part of our community. My name is Tara Dunham, and I work with Warren Adams on the Climate Tech Incubator, which is a program that helps incubate climate tech businesses here in Maine. We launched thanks to funding from the Governor's Energy Office in September of last year, and just a mere 5 months later, we have 16 startup members in our organization. We run educational programming. We give them access to all of the amazing resources here at the Rue Institute and Northeastern University more broadly. We have mentors and residents and advisors and lots of different programs to help them get more successful more quickly. So thank you so much for coming. I would love to talk with any of you after this session. We'll wrap at 1. We'll have some time for question and answer, and we'll be around if anybody wants to talk or see more demos or anything like that. So thank you so much for coming. The bathrooms are in the hallway right behind here if you need water or restrooms. There are some snacks. Please help yourself. We are recording this and we'll share the story. It's very kind to let us share the recording after the event. So if you want to go back and revisit anything, you'll be able to. And without further ado, may I please welcome Stuart Davies from ORPC to share a little bit about his organization and the work in water energy.
Yeah, thank you very much. I'm going to, so I'm not staring at the screen all day. I'm going to try and coordinate moving my laptop at the same time here. So I'm not sure I'm athletic enough for that, but we'll see how this goes. So um, anyway, appreciate the both the RU Institute and E2 Tech inviting ORPC here to present today. I've been with ORPC since 2020. I was brought on board as CEO to really help the company commercialize our systems and scale up. So excited to share with you the progress we're making and our plans here for the near future. I thought I'd start. There we go. From Agendas Day, I thought I'd start just kind of giving the basics on what is marine energy, a little bit of an overview on ORPC, talk about our current market opportunities, and then wrap things up. We'll try not to ruin your lunch hour too much. So what is marine energy? There's several forms of marine energy. The three that are most commonly talked about are tidal energy, which is generating electricity from the movement of the ebb and flow of the tides. Both river and ocean current are very similar, so you just have rapidly moving water that you're converting that into electricity, or wave energy, so you're you're extracting energy from the motion of waves. Those are when people are talking about, that's the most advanced part of our industry. There's also things like ocean thermal, seawater air conditioning, as well as salinity gradients that are a little more in their infancy, but also are broadly in the same category. Ocean Energy Europe is probably our leading advocate group globally. They forecast that marine energy will generate about 53 billion in euros annually by 2050. And they are forecasting that Europe will get about 10% of its electricity consumption from marine energy by 2050. So this is a large market opportunity. That's just tidal and wave. If you look at rivers, we'll talk about the size of that as well. It's not included in those numbers. Importantly about marine energy is we know where the resources are. Global tidal resources are well understood. So when we're thinking about tidal projects, or we get an inbound inquiry from, we've had inquiries from over 70 countries. We kind of know, where the hotspots are and can really focus our attention on those locations. And the industry is doing that as a whole. Same on the river side. So on the rivers, we estimate the North American market's about an $80 billion total market, not an annual market. We think the global market is about 15 to 20 times that size. And similar to tidal energy, we know where the resources are broadly. So if we get inbound requests from, Colombia, for example, we're really interested in those projects. We know there's a lot of moving water. You can see the west coast of South America. We're very active in Patagonia, Chile, some major rivers down there. And then obviously, if you look in Western Canada and Alaska, as well and into Quebec, a lot of opportunities there. And you can see in the developing world, Sub-Saharan Africa, Southeast Asia, and into the Southeast Asian islands. A lot of opportunities for us there. Importantly, I just had this question before we kicked off. We're not looking to compete with wind and solar. We actually think we're a good complement to wind and solar. If you look at this chart on the right, this is if you look at the chart on the right, I don't know why it's going backwards here. There was a study done to look at the solar patterns throughout the months of the year, the wind patterns throughout the months of the year, and overlaying the tidal cycle. So the solar resources in yellow, as you could imagine, in the summer, a lot more solar energy. The wind, actually a little more wind energy over the winter. But you can see how tidal energy and the predictability and consistency of that is throughout the year. And what that enables, when you look at a grid of the future, what that means is you can install 15 to 30% less capacity of wind, solar, and tidal to meet a scenario that only had wind and solar, and have 50 to 70% less battery storage. So tidal energy will improve the reliability and stability of the grids as well. And so, we think there's a significant role for marine energy to play here in a renewable energy future. You know, marine energy has been talked about for 20 years. Why marine energy and why now? I think, solar and wind have had a great 20-year run. I think everyone's gotten comfortable with those technologies. They brought their costs down. But I think the world is now recognizing we need baseload electricity to complement those resources. Sorry, I don't know if I'm not pointing at the right. Am I bumping something on this? Okay. So, as you think about baseload solutions, there's really kind of four popular, streams that are out there right now. One is to keep burning fossil fuels and to capture the emissions. So that's, CCS and direct air capture. There's small modular reactors. Clearly those have, not in my backyard issues when you think about what the long-term waste product of that is. You can continue to go with wind and solar and hopefully, just build a lot of batteries. Clearly right now, lithium, the overall supply of lithium, it's a very dirty process to mine lithium and water intensive. And so challenges there. So we think marine energy can really play a role here over the next 20 years to be that baseload electricity solution. Jumping to ORPC, we've been around for 20 years. We're actually celebrating our 20th anniversary. We have 50 employees. We're based here in Portland, Maine, right on Commercial Street. We have subsidiaries in Quebec, in Ireland, and in Patagonia, Chile. As part of our history, we've worked very well with a number of grant funding agencies to help develop our technology. So MTI has been a huge supporter of ours here in Maine. We've worked closely with the U.S. Department of Energy, Natural Resource Canada, as well as a number of European funding agencies as well. Our footprint in Maine, we've actually spent over $50 million in our history in Maine. Those are various projects as well as obviously paying our staff. We have 32 Maine employees, a supply chain of over 350 partners that really cover the entire state, so 14 of the 16 counties. As you can see, in addition to our Portland headquarters, we have an engineering lab up in Brunswick. We do our tidal testing up in Eastport, and then we do our river testing up in Millinocket, Maine. So really, we touch a lot of different parts of the state in our research and development efforts. This is a quick photo of our turbine. As you can see, it's called a cross-flow turbine technology. It's 96% air, rotates very slowly. We'll talk about fish passage and interaction. We think it doesn't impact the marine environment, but obviously, a very different design. You saw some of the other images earlier that are more axial flow that look like wind turbines. Ours is a cross-flow technology. As you can see on the left, this is what our river power system. It's called our RivGen power system. You can see here but that turbine is here sitting on top of the chassis which then sits on pontoons. We've designed this system with remote locations in mind. A lot of these locations don't have heavy equipment to install a large wind turbine, for example. We just need a front end loader or a backhoe, so it's designed to be easily transportable and then easy to assemble. Once you assemble it, you push it out into the water. It's a pontoon boat, so we can move that around. As you can see the picture on the right, this is our remote community called Igiagig, Alaska. We've been operating there for 5 years, but we have 2 devices. You can see the one on the picture on the right, the one is at the surface, and the pontoons fill with water, and then it goes down to the bottom of the river, release a brake, and it starts rotating with the river current, and which turns the turbine, which turns the generator, and we bring that power and data cable to shore to bring that electricity to shore. If we need to do maintenance, we can blow air into the turbines, bring it back to the surface. Very easy to pull a small vessel up to do any kind of inspection or maintenance on the device. One of these systems will generate between 200 and 600 megawatt hours a year. Again, it's clicking away at 24 hours a day, 7 days a week. That's enough to power about 25 US homes. Obviously, the needs in the developing world for electricity are much lower per household. So that's about 1,500 homes in a place like Nigeria. Minimal land impact. Obviously, we're underwater. Water is 800 times the density of air, so we need a much smaller footprint. And then with regard to marine life, one of the reasons we've worked with Iggy is they're one of the largest sockeye salmon runs in North America. We've had over 100 million fish pass by our devices, no recorded fish injuries or fish mortalities. We've had national labs involved. We've had Alaska Fish and Wildlife, again, all doing monitoring, especially during the smolt out-migration season. In addition, I think one of the reasons I joined ORPC is I really love the mission of the company. So we're helping these remote communities get off diesel. That's saving them the electricity costs, typically on the order of 30 to 50%, but it's also reducing carbon emissions. So one of our devices replacing a diesel generator. We had a study done by an institute in Ireland. Their conclusion was it would lead to up to a 98% reduction in CO2 emissions over looking at a life cycle analysis over 20 years. I mentioned our footprint. So if you look at our footprint compared to solar, wind, and comparing us to solar and wind, if you want to generate 1,000 megawatt hours, you need about 175 kilowatts of regen capacity. That's the little blue square in the middle of the river. For wind, you'd need about double that size, and then for solar, you'd need about 2.5 times that size. Our project in Iggy, it's a first of its kind microgrid. This can be replicated in communities around the world. What we have there is 2 RivGen power systems. Schneider Electric has installed a battery and a smart microgrid controller. And so when that system operates, it moves the diesel generators to backup role. So it is a grid forming technology. When this is operating, depending on the time of the year, the community of Iggy should be able to operate with their diesels off between 60 and 90% of the time. In terms of our expansion, so we have the 2 units deployed in Alaska. We had a RivGen deployed in a 2-year demonstration in Manitoba. That is in storage right now. We'll be going into a project in Canada in 2025. We have 2 of our, what we call our modular RivGen devices deployed in Millinocket, Maine. Similar type device structure will be deployed with Shell into the Mississippi River this year. We also will be deploying a RivGen down in Chile this year. In Europe, we just got done doing a 2-month test of a tidal device. That's our first step toward developing a 1 to 2 megawatt scale tidal device. We recently in December were awarded a grant to deploy a RivGen in Bordeaux, France in 2026. And then finally back to Maine. Again, I mentioned we do a lot of testing of our tidal devices in Eastport. We did a 2023 test of our next generation community scale tidal system in Eastport in 2023. Moving to the current market opportunity, we see 2 opportunities. That those remote communities that are on diesel generators, there's about 1 billion people who live on diesel, another 1 billion who don't have access to electricity at all. The people who are on diesel pay between 40 cents and $2 a kilowatt hour. In the US and Canada, there's a series of tax credits that are now available that haven't been available in a decade for our industry. There's also tax credits in Canada, as well as a number of grant programs in both the US and Canada for these communities to finance these. We also are talking to investors, project investors, about starting to do projects and lenders about financing projects. On the other opportunities with industrial customers, people like Shell, the Buffalo Sewer Authority, again, they're getting concerned about grid reliability and looking for 24/7 renewable solutions. Maybe starting with the remote community market first. Again, as I mentioned, they pay between 40 cents and $1.40 a kilowatt hour. That's 5 to 10 times what the average American pays for electricity. If you look at just fuel costs alone, at $3 to $7 a gallon, That translates into 25 to 58 cents a kilowatt hour. During COVID, there were times where they were paying $15 to $16 a gallon for diesel. We can supply electricity to these communities in the 15 to 35 cent range. So we think there's a number of opportunities to not only save these communities money, but also reduce their emissions, reduce noise pollution. And these projects have a material impact just given how dirty from a pollution standpoint diesel generators are. So if you look at Maine, we have a lot of hydro, our grid has a lot of hydro mix. So we have a relatively clean grid. I think if you look at all the states, I think we're ranked number 4 or number 5 in terms of the cleanest grid. So when we add a megawatt of renewables here, it has versus in a remote community off of diesel, taking off that diesel generator has about a 7 times impact versus adding renewables here in Maine. Talking about the opportunity for diesel generation globally, the World Bank did a study a couple of years ago of 167 developing countries. Again, this covers kind of that 2 billion people that I talked about. Their number was there's 840 million people that live on intermittent and unreliable diesel generation. The installed capacity is 20 to 30 million sites and equivalent to 750 to 1,000 large coal plants. They spend 30 to 50 billion dollars a year on diesel fuel alone. And again, similar cost conclusions, 40 cents to several dollars a kilowatt hour. These communities alone generate about 100 million metric tons of CO2 emissions a year just from running diesels on a backup basis. The other challenge for these communities is you have to transport this diesel. So often it's on barges, often it's on planes. Those planes tend to be 50, 60 years old. There was a crash recently in Alaska of one of these aircraft. But there's consistent stories every year of spills, of leakage, and so these communities really, from a market pull standpoint, they really want to move off diesels. They're loud, they're dirty, and they put their communities at risk. So what activities are we doing here in the? I'm sorry, I didn't forward that slide. What activities are we doing around the world? A quick trip around the world. In Alaska, our big project is working with the Alaska Village Electric Co-op. They have 59 communities on diesel generation. We just completed the first phase of this project where we evaluated all those communities. We're now going back to the top 10, and we're doing site assessments this summer. We're actually going to do some ice studies this winter. And the idea here is to replicate that Igiugig project in 20 or 30 of these communities over the next 3 to 5 years. In Canada, we had 5 different communities in the last round of an NRCan funding program submit applications to deploy our technologies. That was from 4 different provinces. Talking about where we know the river resources, the blue lines here are the rivers in Canada. The red dots are where people are on diesel generation, and then the other circles are the tidal resource. So there's a river and tidal play here in Canada as well as Alaska, but we're working with over 25 communities on projects right now. In South America, our most active countries are Chile, Brazil, and Colombia. We should in Brazil here in the first quarter there's a global funding agency who's going to looking to fund a project. We're waiting on some final permitting in Brazil, but that would involve installing 3 of our units in the Amazon River. In Chile, we're working in a community called Chile Chico. I'll touch on that in a second. And then in Colombia, we're working with a couple groups that are, one is now actively marketing our solutions along the river systems in Colombia. So we're hoping that will be converting to projects here over the next few years. Just quickly on Chile Chico, it's in the central part of Patagonia. Importantly for us, it's in the headwaters of what's called the Bacar River. It's one of the most powerful rivers in South America. If you look on this map from the Puerto Bertrán, which is a small town, through Cochrane down to Tortel, you can see that's where the big Bacar River runs, but also Route 7 runs there. And that's where the single grid line through that part of Patagonia. So we can put devices all along that river system and connect into Edelweiss grid. So the important thing about this project, is it'll be our first deployment in Chile, but we'll also be connecting into Edelweiss grid, do all of that permitting. And so we think that will just start a conveyor belt of projects for us in this region over the next 3 to 5 years. Finally, in sub-Saharan Africa, we have a number of activities there. We've had outreach from a number of countries. Probably the most interesting one right now is in Zimbabwe. So they're in a serious drought, so you would not think they would be wanting to talk to us during the middle of a drought. But some of their major rivers, they've had hydro facilities actually turn off. They've lost 30 to 40% of their electricity capacity. But some of the major rivers that are still running, they're interested in us, potentially deploying systems there, and again, to provide baseload electricity. Quickly to the B2B opportunity. Again, if you kind of step back for a minute and say, what is the transition in the United States alone going to involve? We're going to need to add 3,500 terawatt hours of renewables to get both to convert our fossil fuels, which is about 2,500 terawatt hours a year, and then add another 1,000 terawatt hours of new capacity, which is the electrification of everything like vehicle charging. And then it's things like AI and the rapid growth there. I think if you read the headlines in the news over the last 6 months, big tech has certainly caught on to this trend and is trying to make sure that they have baseload renewable electricity that they have under their control. So you may have seen Microsoft is working with a group on restarting one of the nuclear facilities at 3 Mile Island. You had a deal with Google, Microsoft, Nucor, which is a steel plant, largest steel manufacturer in the U.S., and Amazon with Duke Energy, where they paid premium prices to make sure they're the last ones turned off on the grid. And then you're seeing investments from like Google and Amazon into geothermal and modular reactor companies as they're again, scouring the globe for baseload renewables. We think when you think about that combination with what we're requiring our houses to do over the next 20 years, where we're going to work from home, so it's hard to turn off the electricity when your employees work at home, and it's going to power your car to drive to work. So it's going to be very challenging for these grids to turn off residential use as well. So we think there's, this is setting up for a lot of small and mid-sized industrial users to really get pinched here in the middle as this trend plays out. And the people we're working with, like the Buffalo Sewer Authority and Shell, are already seeing these. But just to give you an idea of the demand from data centers, largely driven by AI, just in the last 4 years, they've added 200 terawatt hours of demand growth globally. So 1 terawatt hour can power about 90,000 homes. That's the equivalent to adding 19 million U.S. households of electricity in just 4 years. And unfortunately, we've spent the last 15 minutes talking about diesel generators, but how are people reacting to that, whether it's an industrial use, whether it's people are worried about the reliability of their electricity at home? People are returning back to diesel generators. So that market's gone from a 0% growth market to growing at 10% a year. So when you think of all the pollutive impacts, we're really going the wrong way here with powering our sorry, didn't flip the slide, with power, how we're coming up with baseload solutions. So again, we see this as a real opportunity for us in this industrial user base. Again, we know where the river resources are. Obviously the Mississippi River is a major opportunity for us. On the Mississippi, we're working with Shell down in Louisiana. It's a demonstration project that we're going to do with them in 2025, adjacent to one of their facilities along the Mississippi River. Initially, we're going to explore different use cases for the electricity, from EV charging to eventually hooking into their some of the use cases for their facility. We could power their dock. But to just talk about the energy density, you can see this is a 50 to 100 units of our devices as a showing you what kind of space in the river we would take up. So the benefits of the density of water enable us to really pack a punch in a pretty tight area. In Buffalo, we're working with the Buffalo Sewer Authority. Again, I don't think anyone wants to have a sewer authority wastewater treatment plant shut down. That means the raw sewage goes straight into the river. So they need always on power. So we're talking with them. We've been exploring funding for this project. The initial phase would be to do a 3-unit deployment in the Niagara River. And then eventually you can see that purple box would be a 50 to 100 unit deployment where we could connect into the New York grid or find other users in the Buffalo area who would want to take that electricity. The good news from this project is we have a preliminary FERC permit in place. And so, again, working with the Sewer Authority on lining up funding to move that project forward. And we can move on a pretty quick timeline with that permit in place now. Moving north to Canada, we have a couple projects in the Montreal area. One is where you see the 8 megawatts on this slide, where we're working with the Ganawake community about deploying a device there. Eventually, they have a new community center going in, so they would need a couple dozen devices to power that as they construct it. And then we're working under an NRCan program. We've made it through the first round. We should hear the final decision in April. We put in an application with the Parc Jean Drapeau, which is pictured here in the lower right. Hydro-Quebec, which is the utility of Quebec, is also involved. But it would involve us in an initial phase in 2026 deploying 2 of our RivGen devices adjacent to the park here in the St. Lawrence River, and then eventually deploy another 8 to 10 a couple of years later. For example, with the park, there's a lot of interest in using the swimming pool year-round, but they don't have enough heat. They actually bring in natural gas to heat their facilities. It's very expensive. It's not a gas line. And so there's an opportunity for us to reduce their cost and take them to a renewable energy solution, but also enable them to operate year-round from a business return standpoint. And then finally, in Bordeaux, France, as I mentioned earlier, we were recently awarded an opportunity here. We're excited about this. This will be our first RivGen deployment in Europe. In addition, France has great river and tidal resources. We think there's 100 to 200 megawatts of potential in this estuary, and then 3.5 of gigawatts of tidal resource in France. The other part of this project is it actually provides funding for doing business development in France, Germany, Switzerland, and the Netherlands. So it's really going to enable us to open up the European market for us. Shifting quickly to tidal energy, we'll start in Alaska. We're working under a Department of Energy Water Power Technology Office grant on a project to develop 1 to 5 megawatts in Cook Inlet. We have named it the American Tidal Energy Project. There's the website if people are interested in exploring. This first phase runs through April. It's got a number of different things involved with that, from site assessment to workforce development to developing a website and to begin to lay out studies of marine life like the beluga, Cook Inlet beluga whale population. There then will be a down select. We're competing with a competitive project out of the state of Washington. One of those projects will be down selected to, and then you'll be awarded the funding for the phase 2 through 5, which is this $36 million to fully develop that project. What we're excited about is we have a FERC permit in place there. We think the site where we have that permit has 100 to 400 megawatts of potential energy, and Cook Inlet alone has about 18 gigawatts of electricity potential. So if you look at our site, which we call the East Foreland site, it's the #1 tidal site in the U.S., one of the best sites in the world. Peak velocities almost reach 4 meters a second there. Just like you would think about the wind, the stronger the wind blows, the up to a certain point, obviously from an operation standpoint, but the more electricity you can produce. Same for our devices. It's a volumetric equation, so as those velocities get higher, we can produce a significantly more amount of electricity. So very attractive site for us. In addition, tidal energy in the resource just in Cook Inlet could provide over 100% of the electricity needs of Alaska. So what that means is we're talking to the military bases there, other industrial users there. There's, for example, an idle ammonia plant there about not only providing electricity for the various utilities in Alaska, but also different users for the green economy. So green ammonia, green hydrogen, sustainable aviation fuel production. A lot of interesting conversations happening on if you're able to develop the tidal resource, what the end use cases would be for that. Also in Alaska, if you move out to the Aleutian Islands, we're working with the city of False Pass. We're working under congressional directed spending. We've been working with False Pass for the past 7 to 8 years on developing a tidal energy project. This funds the next phase of that. This is doing final site characterization, some grid upgrades, and getting all the permitting and licensing in place to then come back and deploy tidal devices and convert that community off diesel generation. They also have fish processing there. So industrial users don't get any subsidies to operate in Alaska. Some of the communities get subsidies to run diesels. So there's really an opportunity to lower the cost of operations of those fish processing plants, which will be a real boost to the local economy in terms of job creation as well. And then finally wrapping up with coming all the way back to Maine. If you look at Millinocket, we're on the site of the former Great Northern Paper Mill. You can see the picture on the bottom right is the location. We're just downstream of a hydropower facility. We think it's an ideal location as a long-term testing center. We can move our devices in and out of the water in a matter of hours. Enables us to test new turbine designs, enables us to test new components. We're always trying to get smarter on how to evaluate river resources. It's a very complex actually flow in this river section of the river. So enabling us to refine our skills there with how to measure rivers. And then eventually we'd love to do something like install EV charging to demonstrate that use case here in Millinocket. In Millinocket, we're working under a different Department of Energy program, which is called the ORPC program. What ORPC asks you to do is to kind of say, okay, well, you've done this, throw that out, create the next generation and test that. So that's what this Sharks program is. So we'll be building and testing our next generation turbine under this program. The target of this program is to deliver electricity at 8.5 cents a kilowatt hour. We'll be testing this Sharks turbine in Millinocket sometime in the second quarter. We are hoping the drought in Maine ends between now and then. It'd be nice to have more water flow than we're getting right now. But, I think if successful, this turbine is looking like a 50% reduction in the cost of electricity that we could provide, to our various customers. So really big opportunity for us here. We have a lot of the team's time being spent on that, and we're really excited to see the results of this test later this year. And then finally, a lot gets written about our activities in Eastport. We've been working there for well over a decade. They are working on a microgrid project that we are part of. If people are not familiar with Eastport, they're at the end of a 40-mile transmission line. They have outages. They have high electricity prices. One of the things they're trying to do, one of the benefits of COVID for Eastport is they had cruise vessels start to show up and dock at their facility. And so there's a real opportunity for them to provide more electricity to those vessels, which is obviously would increase the load. It's going to more than double the demand of electricity there. But as you think about those cruise ships getting more and more electrified, it's a real opportunity for the community to have those vessels then dock and all the economic benefits of having those tourists visit Eastport. So they're developing a microgrid. They're basically going to turn the transmission line around. So they'll have a microgrid out on the island. And then in weather events, they can actually island off from the Versant power grid and be its own microgrid. So they'll be part of this project. The first phase, they're installing solar now. They're going to install a battery. And then we'll be in phase 2 later this decade, where we'll come back with tidal energy and provide the baseload resource into this project. So just to wrap up, there's a growing importance for energy independence and energy security, whether it's a remote community, whether it's industrial users. As the grid is getting strained by this growth, the reliability is becoming a growing concern. We're seeing this with industrial users as well as remote communities. Demand for baseload electricity solutions is high, and it's growing. As we're starting to see the limitations of intermittent renewables, they're continuing to progress. I think the battery technology has not kept up, and so there's this growing need for baseload electricity. So we think, given the consistency and reliability of marine energy, that marine energy can play an important role in this future to really help the transition of adoption of more renewables, including wind and solar, because of the benefits that we talked about earlier in the discussion. So thank you very much. You want to do questions? Okay. No questions from ORPC employees.
I'll start. The governor would like us to, our sector, that is, double the number of clean energy jobs, which is here on your circle diagram, clean energy jobs, to get from like 15,000 to 30,000. And I know that the turbines that are in Chile were actually manufactured in Millinocket. So can you talk a little bit about the jobs that you're creating in Maine? Not necessarily just R&D, but also manufacturing.
Sure.
And what other
Yeah.
jobs might be coming out of the sector?
Sure. And I think, as I mentioned, I took over in 2020. I think we had 14 or 15 Maine employees when I started. So we're up to 32 here. So as we are, as our business is growing globally, our footprint in Maine is growing as well. I think, as I mentioned, we have over 350 suppliers in Maine. If you think about our RivGen device, we have 58 different suppliers. So there's a lot of components that go into this. We regularly go out to Maine-based companies to find out whether they can provide solutions. One of the things we're trying to do with our existing devices is to say, okay, this is our existing supplier. What can they do with us to work as we scale? Can they scale with us, and can they reduce costs? But also to see if there's other companies out there who have more innovative solutions that may fit into our, may be able to make our various components in a more efficient way, or have a thought on a new design that we could incorporate into our system. So we're always open to discussion with manufacturers and suppliers in Maine. If you going back to what you were talking about, the devices we deployed in Millinocket, the devices that are in Alaska, all of those pontoons and chassis were made in Maine, and a number of the components. So I don't know what the look through is in terms of jobs, but we certainly, whether it's Millinocket Fab or down East Maine, we've tried to keep them busy and are hoping to keep them busier going forward here as we scale up.
Hi. With a new administration coming in, I'm curious about the potential impact on federal funding, regulation, that sort of thing, which obviously could be quite different, shall we say.
I think we're going to start knowing the answer to those questions in a couple of weeks. So, but from our perspective on the regulatory front, one of the things that I spend some of my time on is down in DC working with, the National Hydropower Association covers traditional hydro as well as marine energy. So working with them on some of the permitting challenges, and we're hoping that some of those efforts that we've done over the last couple of years will actually streamline some of the permitting process. What we've tried to do is work with, as I mentioned, all of the studies we've done with the migrating fish in sockeye salmon in Alaska, is really to try and collect data and work with those agencies to retire risk, to streamline that permitting process. So good example is Alaska Fish and Game was worried about adult sockeye salmon coming up the river. After 2 to 3 years of study, they recognized there was we had cameras on the devices, drop cameras, drone cameras, that literally zero sockeye salmon interacted with our devices. And intuitively, it makes sense. We want to put the device in the fastest flowing part of the river, and the really old fish who's coming upriver, the last place they want to swim is against the strongest current, so they go up the sides of the river. So the community who's lived there for 10,000 years pointed that out right away, but where they had all their fishing lines in place. But so it's trying to retire those risks so we can streamline permitting. But I think on a funding side, there's concerns on what will happen to some of the funding with regard to the Department of Energy, for example. The Office of Clean Energy Demonstration has been mentioned a number of times by former Trump officials in the last administration, or some people who may be nominated into new positions or work in that administration. So there are a few programs that we think may be at risk going forward. And obviously, the DOGE process may result in some cuts, but from a environmental permitting standpoint, we think it'll be a positive for moving projects from idea stage into execution.
Oh, yeah.
Hi.
Hi. So you mentioned one of the communities you've been working with for about 8 years and are awaiting some funding to come through. Where are they going for funding, and what are some of their biggest challenges in receiving it?
Yeah, so I don't think we've been working with a community for 8 years that doesn't have funding. That's okay. There's a number of programs. So the Department of Energy, for example, has an office, Indian Energy Office, and they regularly fund programs. Once your technology reaches a certain phase of commercialization, they will support programs that use your technology. So they were one of the offices that funded part of the program, part of the project in Igiagig. The U.S. Department of Agriculture has programs, some of the states have programs as well. So there's kind of federal programs as well as states. But Department of Energy, USDA are probably the two biggest programs. On the Canadian side, again, many of the provinces have clean energy targets, and so they have funding programs. And then NRCan has got periodic programs for helping communities. I think when you look at, I think it's a well-recognized problem that these communities pay an extraordinarily high cost of electricity, and so I think there's broad-based support for helping to spur economic growth. If you look demographically, for example, in Canada, in the First Nation communities, they have the highest population growth, and so there's a real desire among First Nation communities to keep that next generation there. So you need more. Not only do you want to retire diesels, but you actually need more capacity there. So there's a lot of the discussions we're having in these communities is actually about growth as much as anything. I think you had a question.
Yes, it was great hearing your presentation. I was watching it on Zoom on the way over, and I've been following ORPC for the past 4 years, and I know that the cost per kilowatt hour is one of the key factors by which clients evaluate your services. So what have you learned over the past 4 years in terms of lessons on how to lower that amount? What are some of the factors?
So, if you think about the cost the cost to provide electricity, it's what's your upfront capital cost, what's your maintenance cost, and then what's the output generated by your device. So, I think each of our successive iterations of the turbine have resulted in improved performance. We've switched manufacturers of the turbine foils, for example. We've had much more consistency of product, which has helped not only performance, but also if you think of durability and reliability, that's helped quite a bit. Every time, one of the things that I didn't mention is, we've done 18 deployments. So one of the things our view is, get devices in the water. Obviously, it helps us learn about the permitting process and how to do that, and whether it's in various states or countries. But also, we learn by doing. And so, we've taken, if you think about our 2019 deployment in Igiagig, that took 7 people who were there, 3 or 4 weeks. We can now send a 2-person team. And when we did the deployment in Canada, it was a 2-person team, and we were done in 7 to 10 days. So all of that, clearly can reduce that power of electricity. And then on the maintenance side, we're trying to build robust systems that can operate for several years underwater without having to bring those up, and really build a durable product that as by the time you travel out to these, the cost of that adds up. So all of that goes into that. And then I think the fourth is really growing our supply chain. So trying to find new potential suppliers who can do things cheaper and faster. So I mentioned the foil switch. That we worked with that company. We actually invested in some tooling. So they can produce a foil for us they can produce it in a week. It used to take our old supplier several months. That foil, that upfront cost is there. So the cost of those incremental foils is a fraction of what it would be to under the old process. There was no efficiency gains there. So long-winded answer, but those are some of the things we've been doing.
Hi. It sounds as though speed to market may be an advantage that you have, but I'm trying to get my arms around what the timeline is in getting up and running and delivering. And hand in hand with that, I'm not clear on what infrastructure is required to get from the device to the end user. And then the third part of that is the geographic reach, if you will, or what's the economies of deciding how many devices and how many communities or geography can be served. So just trying to get my arms around that. Thank you.
Sure. I'll try and see if I can answer all the, remember all those. So if you think about your last question, obviously, if the community's got 75 people, they're not going to need 10 devices. They're going to need 1 or 2 devices. So really, it first starts with what's the load of a community and what's the projected growth of that. And then that will size the opportunity. Some of these communities have 50 to 100 people. Some have, in Canada, some of them can have several thousand. So really, it's going to depend on first the overall load. Second is obviously the velocity and depth of the resource, and figuring out the area that has the attractive economics there. And I mentioned river velocities. Going from 2.25 meters a second to 2.5 meters a second is a 40 or 50% increase in output. So I talked about our work in Millinocket to really better understand the dynamics in rivers. It's an important thing. One of the things we're talking with some communities about is, the community may be here, but maybe a mile or 2 upstream, maybe the ideal hotspot. Could you use something like and I'm saying this because I drive one, but like a Ford F-150 Lightning, where you are charging those up and driving those down to the community, just hooking those into the community, as opposed to doing these expensive grid modifications, or not that we need them, but a lot of times there's grid upgrades that needed to be done. In terms of the infrastructure we need, we bring that power and data cable to shore into what we call a shore station. It's a box on shore that basically converts that power to have so we can deliver the electricity on the right voltage and amperage that the community would need. So that's the only other infrastructure we're adding to the shore. So it's not, again, they can vary in size. In Alaska, we have a rather large container because it's cold and there's grizzly bears in the area. So you need to work in a safe environment. But this can be much smaller on a dock for Shell that doesn't have harsh weather conditions other than the occasional hurricane. You can that can be a much smaller component. Did I answer all those? Okay. Yeah, it depends on the project. I mean, I think from a timeline standpoint, let's take the Alaska Village Electric Cooperative project. We'll be working while we're doing site assessment work. We'll be working on getting initial permitting. So there's kind of this first phase where you can deploy under FERC jurisdiction, and then you can convert that to what's called a pilot's license, which basically gives you 10 years to operate, and then you move to a full project licensing. So we think we can get devices in the water relatively quickly under some of these preliminary permits, not only to demonstrate, but get FERC and the other permitting agencies comfortable with what we're doing and the technology in the area. So then we can convert to that pilot and eventual commercial license. So we think it's a kind of a 2-year timeline to get devices into the water, and then for a permanent established structure, that's a longer process. But we hope to be have devices operating during that time.
And then I have a last question from the chat. With Morocco's extensive coastline, high tidal energy potential, and strategic location at the Strait of Gibraltar, along with the world-renowned ports like Tanger Med and decent mega projects in the south, such as Dakhla Atlantic, coupled with increasing international and government investment in renewables, how does ORPC envision its tidal energy technology integrating into this landscape? Can Morocco act as a gateway for scaling ORPC solutions across North Africa?
So I think this is what I'm joined here with Nate Johnson, who's runs our business development efforts. I think this is what we love about our job. We've had outreach from over 70 countries. Happy to be we'd be happy to talk to the person about the opportunity. I think it's very similar to what we're talking to people in Kenya about. There's an interesting tidal resource off the coast of Kenya. I'd have to go back and study the maps of Morocco and how it flows through the Straits of Gibraltar. But we're certainly willing to explore that. But I think, if you look at a number of countries that we're talking to, whether it's programs in the Philippines, Indonesia, Kenya, there's a high use of diesel, or there's unreliable and expensive power. And so, we can bring that reliable electricity to port facilities or communities that are ocean or sea-based, Mediterranean sea-based communities. So happy to speak to them.
Thanks. And we are at time. So we're going to end the virtual part of the Zoom. And then, Stuart, if you have a few minutes to hang out and answer any more questions or shake some hands before you head out, if you can catch Stuart, then please do. I will be around, Warren will be around, E2 Tech will be around for a little bit. So if you have any questions for us, please come find us. Thank you so much for joining us. We hope to see you at a future speaker series session, and have a wonderful day.
Thank you, everyone.